Hi everyone, my name is Melvyn. I'm an associate professor in the Faculty of Economics at the University of Cambridge, and I'll be teaching a course on the Data Science Winter School on machine learning for economists and policymakers. The material that I'll be using features heavily in one of the courses in the new MPhil degree to be introduced at the Faculty of Economics in Cambridge in the fall of 2024. And the degree covers a wide range of data science topics, and the course that I'm teaching is on causal estimation. So a lot of the material will come from that. So the question, if you're interested in joining us in December in the Data Science Winter School, the question is, what will we be covering? We will cover topics across three main areas: machine learning, the basics of machine learning techniques, topics in statistics, and topics in econometrics. And those three topics and the intersection thereof allow us to consider three main literatures. The literatures is causal estimation inference, using alternative methods for identification. So those of you who are coming from an econometric background with the requisite knowledge on identification, all of that knowledge and understanding carries forward into consideration when we start considering alternative methods for estimation using non-parametric techniques. So that's one of the literatures. The other literature is a literature in high dimensional statistics, such as Lasso, which allows us to manage a bias variance trade-off that follows from a framework we've got where we have a very large number of possible features that might be included in the model. The other literature, again, is the literature on machine learning algorithms for prediction problems. Some of you already understand that if we think about causal estimation, think about the reduced form regression for an endogenous variable. That is a prediction problem. So we can leverage the way we might start to think about this. We can leverage the ability to manage high dimensionality and prediction problems when we start thinking about causal estimation. So understanding of machine learning algorithms for prediction problems will be crucial when we start actually integrating that within a causal framework. I can't sort of underestimate how challenging the vernacular around these methods are. So machine learning methods for prediction and classification and causal effects, the notion of double robust methods when you move from using Lasso for a prediction problem to using Lasso to a causal model, we will see that the framework we will use will look like a so-called double Lasso method. And that double Lasso method will be applied to in the first instance, to a linear model, but can be also used where we're interested in managing high dimensionality in a causal problem, but where we are agnostic in terms of the functional form. So then we have the notion of double debiased machine learning methods. So the way the course will work, it will layer up in terms of starting with an simple OLS framework, where under certain conditions, the OLS is the best estimator in terms of either a prediction or the notion of a blue estimator when we're in a causal environment. So other vernaculars that you will face and hopefully understand in the course is notions of honest estimation and generalized random forests. So sort of following up from what I've just been saying, the course has multiple but well-defined points of departure. The conditional expectation function and OLS regression, as I've said, high-dimensional methods in statistics, regression and the Frisch-Wall-Lovell theorem, which is going to be critical when we start thinking about introducing orthogonalization, a method that allows us to utilize lasso in a causal setting. We will also look at the genesis of modern non-parametric methods such as neural networks, gradient boosting, random forest. We'd look at that, the genesis of those methods in terms of simple kernel-based techniques. We'll also consider treatment effects as a motivating example for bringing in causal estimation using machine learning methods. Again, that problem has a genesis, one might say, in terms of the partial linear model, where we have a single treatment parameter that we might constrain to be linear in an effect, but alongside a high dimensional set of controls. And how do we actually deal with that high dimensional set of controls? So these are the points of departure. Applications that we use, a very wide range of applications, looking at causal forests of heterogeneous response. Again, here we might have a benchmark linear treatment effect estimator with a pre-specified and chosen set of controls alongside a linear constant effect treatment effect. And we depart from that by allowing the treatment effects to be heterogeneous, but not pre-specifying the form of the heterogeneity, alongside being agnostic on the function in terms of the functional form. We'll look at that problem in terms of time of use electricity prices. We also look at the impact of institutions on growth, and there I think it's important to emphasize that the notions of big data is not just a question of the number of records, but it's a question of the number of observations relative to the number of possible controls. So in this case, a very famous paper, the number of observations, i.e. the number of countries, is relatively small, but the number of possible drivers of growth, especially in the context of how you measure geography, is very high. So we will look at examples of machine learning methods in that context. In finance, we have there's a very big component or area where machine learning methods are used in finance. We briefly mentioned that literature and utilize a number of examples, such as predicting financial crisis and explaining the post-earnings announcement drift. So why should you take the course? There's a number of potentially overlapping reasons. You're a user of machine learning, but your understanding is limited to prediction problems. You're an economist or social scientist more generally, with a background in causal methods for parametric methods. Again, you want to move away from a parametric framework and consider the use of machine learning techniques. You could be a policymaker, and you're hiring new analysts. You're aware of all the buzz around machine learning, and you want to open up that black box and understand both the benefits and the limitations of these methods. You could work in industry, and again, you may be a manager, you could be a CEO, and you want to get a better sense of how these methods might be used. They might be used, for example, to understand the drivers of consumer purchase decisions, or indeed the propensity to fall on a loan. So that gives you a sense of why you might wish to take the course. I should also say there's a new addition to the course. This course has been taught in a number of places. So since the summer, there's a new component of the course, and it's called unlocking. So one of the other topics we will do is unlocking the value of unstructured data. What I mean by that is text. So no one could have missed all the media coverage and subsequent discussions around the introduction of large language models, and particularly ChatGPT in November 2022. What we will do is review the precursors to large language models and examine the underlying architecture of GPT and other large language models such as BERT. And we provide an application of these methods based on extracting sentiment indicators from the central bank speeches, and then evaluate the impact of that on stock prices. So there's a lot to cover. I really hope you join the course, and I look forward to seeing you in December. Thank you.